today I got an example of driving a servo motor together with Arduino Duo using timer 0 interrupts. So let's check it out. So let's increment or first decrement the PWM by 1. So as you can see, it spins faster the one direction, and if you go below the 1 millisecond time, it doesn't change. So let's go ahead and stop it, and let's start incrementing. So it will go the other way around. And incrementing the value doesn't do really much after the 2 millisecond time on. So let's stop it, and also a simple routine for the servo. So it goes just back and forth all the time. So something like this. So now let's hop into the project and see what we got there. Okay, so we are in the main file. Let's take a look at what we got in the configuration of the ESF. So we have the timer counter added, the GPIO, the delay routines, and for communicating with the Arduino we got the USB device as a CDC. And we got pretty much the same configuration as in the timers example video, with a change of the reload time. So the servo works in the time intervals of 20 milliseconds. So we would like to generate a interrupt every 0.1 milliseconds, so 100 microseconds. So the reload time will be times 10 the previous frequency, something like this. And in the communication, we added some checking for commands. So the stop command, increase, decrease of the time, it stays on, and the routine start. Okay, so in the main function we got the clock in it, for the board, the GPIO, configuration, and configuration of the timer 0, starting the USB, of the delay, and also we got a 2 seconds delay, and after that we print a hello string. So hello string is just the main menu options. Okay, and that's just LED blinking, that's nothing very important. But in the handler of the timer 0 we got, let's take a look first at this. So every time the interrupt is generated, we check if the counter of the interrupts is in the range of the time it has to be on. If it's in this region of the time on, we just simply enable the GPIO as a high output, so it's driven in the set on time period. So if it's like the default 15, it is the value for the servo to be stopped. So it is 1.5 milliseconds time period. Okay, and after the time on, it's set low, and it's got the timer reload value set as 200. So that equals 20 milliseconds for the servo PWM to work. So after every 20 milliseconds, we make the tick counter to 0 and it starts over again. And if we got the routines enabled, we also increase the complete cycle counter. So every 20 milliseconds we increase it. And if we got it enabled, I got a routine that if the counter is below 66, it's rotating one direction. After that, it rotates the different direction. And after that, it just stops, waits a little bit. And then after this value of times, so this times 20 milliseconds, it resets and starts all over again. Okay, so we can do a little modification to this. So let's make it turn a little bit faster than what we got right here. So for example, let's put in 18, and right here let's put something like 12. Okay, so let's build it. Let's get it onto the board, and first of all make sure you got this closed. If you don't and you just reset the board, it will shut down, so make sure not to do this. Okay, so let's get the board and program it. Okay, fine, I'll reset the board. And let's take a look at the servo and also open up the board. Let's type in R and it spins faster, yeah. And it also makes more rotation because it's time-based. The servo that I got, it's a 360, so it just basically rotates. But if you got a standard servo that works 0 to 180, it will work like rotate, stop, and then rotate to the maximum, so 0, 180, and it just stops, so you don't have to worry about going to further and so on. But adding some switches to it, it also can make it work like a 0, 180. So thanks for watching. Hope you find it useful in your projects. If you got some questions, just put them in the comments below. So thanks for watching. See you in the next one.